Hello, good afternoon, everybody. My name is Anang. I'm the instructor, and today I'm going to talk about software engineering. We are going to start with the very first chapter of software engineering. We'll consider what goes into the development of software engineering and every aspect that comes with software engineering. This course is basically for computer science students or people that are or students that are studying computer engineering, just for them to have a better understanding of what goes into the development of a software. Yeah, so that is basically that. And this video is being supported by ProTechAfrica. You can follow us on Facebook and Instagram, and you can also watch our YouTube videos. I also have my email, and then I have my WhatsApp number over there. You can send me an email pertaining to something you do not understand or how you feel about this video that I've developed. This will give me a better understanding to upgrade myself and then do something that is very acceptable to everybody. So I encourage you, do well to send me a mail. And you can also visit protechnologyafrica.com, and then you can get more information at that particular site. Right, so let's go into the first chapter of software engineering. So software engineering, chapter 1, and the instructor Anang, in regards to everybody who is listening, especially to my students. Yeah, so what is the objectives? What are we going to consider under this course, software engineering? We are going to look at what software engineering is. And then over here, we are going to look at the reason, the definitions, or the need for software engineering. And we'll also consider the characteristics of a good software. That is for chapter 1, what we'll be looking at. And then for chapter 2, we'll also consider the requirement analysis and specifications. And we would also look at the various methodologies that goes into software development. Chapter 3, we'll look at the design of a software, the coding and testing that goes into software development, the software maintenance, and then software reliability and quality management. Everything about it, we'll try to explain and see how well our students would understand this course better. So now let's go on. Software engineering. Before we define what software engineering is, I just want us to look at the word software. What is software, and also what engineering also is. Then we group the two together, and then we get a better understanding about it. A software is considered to be a collection of executable programming code associated with libraries and documentations. Software, when made for a specific requirement, is called a software product. So when we have an executable programming code that is associated with libraries and documentations, then we can consider that as a software. So a software is not just a programming code that performs specific tasks, but there are other things that comes with it that has to do with the libraries, and also the documentation of the software also plays a significant role in what qualifies maybe something to be classified as a software. Right, so if we can go on that. It says a software is more than just a program code. A program is an executable code. So then we can know the difference between what a program is and what a software is. Yes, sometimes during interview pertaining to software engineering, you do ask what's the difference between a software and a program. Yeah, so the definition is there. So software is more than just a program. A program is an executable code which serves some computational purposes, right? So that's about it. And then engineering, on the other hand, is all about developing products using well-defined specific scientific principles and methods. So the ability for us to use a well-defined scientific principles and methods is what is called engineering. And I hope we know some of these basic scientific principles and methods, some of the scientific laws that falls into the study of science. Yeah, so that goes into that, and that gives us a better understanding of what engineering is. So for this particular slide, we've talked about what software is, what a program is, and what engineering is. So let's move on. So now let's take the full definition of what software engineering is. I've given three definitions, and then the first one is from the IEEE, which says that the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software. So this is the definition of what IEEE gives us. That is IEEE. And then let's consider the second one. The second one is by Fritz Boyer, a German computer scientist, who defines software engineering as software engineering is the establishment and use of sound engineering principles in order to obtain economically software that is reliable and work efficiently on real machines. So that is the definition by Fritz Bayer. Yeah, so that's about it, where the ability where we can use engineering principles to develop a software for economic purposes, right? And then software engineering is the complete study of the design, development, and maintenance of a software. Once we have designed it, then we can develop it. And once we develop it, we should be also have the access to maintain what we have developed. Yeah, so these are the three definitions that comes under software engineering. Without using software engineering principles, it would be difficult to develop large programs. Yes, so this is very, very important, because in the development of softwares, we do have some things that needs to be considered. We do have some methodologies that needs to be followed. We do have some documentations and procedures that needs to be followed before we develop the software. And it is very, very important, because in the development of the software, it will aid us to develop large programs, complex programs, big programs that can serve a whole lot of functionalities, or it can serve a whole lot of tasks within that particular software we have developed. So there is the need for us to follow the principles of software engineering. There is the need for us to follow a laid down procedure, a laid down steps that would help us in the development process, so that in a quest to build something large and something bigger, we can know where we started from, where we are going, and where we have gotten to. Yeah, so that it will help us, because some of the things that we do are quite basic, and once they are basic, we need to document it. We need to keep track of what we are doing, so that in the future, when we need to call some of these events that we have written, we can know the specific functions that they are supposed to do in our complex program. So without using software engineering principles, it would be difficult to develop large programs. In industry, it is usually needed to develop large programs to accommodate multiple functions. So that explains what I said earlier on. Right. A program with developing such large commercial programs is that the complexity and difficult levels of the program increase exponentially with their size. Yeah, so that's the same thing that I explained, that if we have big programs, I mean, the complexity of the program increases as we add more functionalities to the program. So then there is the need for us to follow some basic principles, some basic instructions, some basic methodologies in our quest to build the complex program. Software engineering helps to reduce these programming complexities. Software engineering principles uses two important techniques to reduce problem complexity, which is abstraction and decomposition. So over here we have two basic principles that is used, or basic technique that is used to reduce the complexity of a problem, and that is by abstraction and decomposition. So we are going to look at what abstraction is, and we are also going to consider what decomposition is. Now, the principle of abstraction implies that a program can be simplified by omitting irrelevant details. In other words, the main purpose of abstraction is to consider only those aspects of the program that are relevant for certain purpose and suppress other aspects that are not relevant for a given purpose. So over here, what the principle of abstraction states is that we try to itemize our details, or we try to put down our details, our problems, and we consider the problems that are relevant for a specific event or for a specific instructions that needs to be followed, and then we tackle them, and then we come to the ones that are of less importance for that specific task, and then we later consider them. So over here it says that what the principle or the concept of abstraction is, that they look at the relevance of every information, and then we try to look at the ones that are relevant, we tackle them, and then the ones that are of less importance, we address them later. So that is the aspect of abstraction. Abstraction. It says once the simpler problem is solved, then the omitted details can be taken into consideration to solve the next lower level abstraction, and so on. Abstraction is a powerful way of reducing the complexity of a problem. So with the help of abstraction, we can break the problems down into what? Into smaller units and tackle them one after the other, considering the ones that are of great importance, the ones that are relevant, and then we look at the ones that are irrelevant later. Right, so that is abstraction. The other approach to tackle problem complexity is decomposition. In this technique, a complex problem is divided into several smaller problems, and then the smaller problems are solved one by one. So over here, we divide the problem into sub problems, and then into smaller units or into smaller basics, and then we solve them one after the other. This is different from abstraction that considers the ones that are relevant and then the ones that are irrelevant. But this one, we divide the problems into smaller units and we solve all the problems. But in our quest to solve all the problems, we tackle them one after the other. One after the other. So over here, we do not discriminate about which program is important and which program is of less important, but provided we have broken the problem into smaller units, we take them unit by unit and we try to solve the problem. Right, so that is with the aspect of decomposition. Decomposition, right. However, in this technique, any random decomposition of a problem into smaller parts will not help. Right, so that is that. So it means that we need to follow a laid down procedure to break the problem into smaller units. without doing them what randomly, right? Okay. The problem has to be decomposed such that each component of the decomposed problem can be solved independently, and then the solution of the different components can be combined to get the full solution. So over here we decompose the problem and we solve them independently, and then we bring all the problems that have been solved together to form a full complex solution. So that is the aspect of decomposition. Break the problems down, solve them independently, and bring the units that have been solved together to accomplish a specific task. A good decomposition of a problem should minimize interaction among various components. It says that if the different subcomponents are interrelated, then the different components cannot be solved separately, and the desired reduction in complexity will not be realized. So now let's look at the need for software. I mean, do we have to? Is there a need for it? Should there be a necessity for the development of a software, or to practice or to study the course software engineering? What is the need behind this? The need of software engineering arises because of higher rate of change in user requirements and environment in which the software is working. Right, so let's look at the various things that would go into the necessity or the need for software engineering, because it could be affected by the requirements and the environment in which the software is working. Right, so if the requirements are specific and the requirement has been designed according to the software, then it should not misbehave. And if the environment is also good, the software should be able to function effectively. So let's look at the needs for that. The first one has to do with large software. It is easier to build a wall than to build a house or a complex building. Likewise, as the size of a software becomes large, engineering has to step in to give it a scientific process. Let me explain this. So, this one has to deal with what? The complexity of a software. Because if you have a series of code that needs to perform a specific task, let's say we have written a code to add some few numbers or something, we can't call it a software. That one is purposely to perform a specific task, addition or computations of some figures. But if we are developing the software to handle, to store, to calculate, to divide, and to help to predict, let's say, formulas that have been given to read, then there is the need for us to what? Have some laid down procedures and documentations down that would help us to achieve this specific task. So over here it says that what? The large complexity of a software is of great necessity. Yes, it's of great necessity. That is why it is talking of building a wall to a house. You can just mount a wall, but in the context of building a house, you have to figure so many things. You have to check even the integrity of the sand or the concentration of the cement and other things that comes into the aspect of the building of a house. Unlike a wall, which is just standing. Right. So much goes into house development or house building than into developing of a wall. So much goes into the development of a software which performs so many tasks or so many functionalities and response to events than running just a simple series of code. Right. So that talks about that. And then we also have scalability. It says that if the software process were not based on scientific and engineering concept, it would be easier to recreate new softwares than to scale an existing one. So when we talk about scalability, that is the ability of the software to expand, the ability of the software to accept new information, the ability of the software to increase as the demand goes higher, the ability of the software to respond to change effectively and then function well. Unlike, let's say, a situation where you have a software that is static, or you have a program that is static that cannot expand. But if we have a software where we have a means whereby the software can grow, it can grow in size, it can grow in functionality, it can grow in, let's say, performing of complex tasks and other things, then it means that there should be some procedures that needs to be factored, so that in a quest of expansion, or in a quest of increasing in development, the software would function well. Right, so that explains the aspect of scalability, the ability of the software to expand. Let's say the software can expand when the need for, let's say, for a banking software that has been developed, and maybe it is working with a particular currency, and all of a sudden we need to change the currency. We should have a means whereby we can do this change, so that the software would accept the new currency that is coming on board, is going to function well, all information pertaining to the software and the expectations of the software is going to respond effectively. I can also use a perfect example of, let's say, the Facebook that we are using. The Facebook we have 10 years ago is different from the Facebook that we are having now. But you see, the Facebook we had before had the ability to be scalable, had the ability to go under scalability, whereby it increased in functionality, it increased in, let's say, the user response and event that occurs on the software. That is, so now we can use Facebook for so many things. We can use it for chatting with friends, we can use it for making calls, we can use it for, let's say, video conferencing and a whole lot. Why? Because the Facebook app or the Facebook software has the ability to be expand, to be scalable. Right, so that explains that concept. And then we also come into cost. The cost, it says, as hardware industries has shown its skills, and huge manufacturing has lowered down the price of computer and electronic hardware, but the cost of software remains high if proper process is not adapted. So over here, there was a time I was telling my students, my operating system students, that you see, it is not if you have a phone, okay, the phone, the physical phone that we see is not what makes the phone expensive, but it is the operating system that makes the phone expensive. And what is the operating system? It is the software that is running the device that makes it expensive. Because a Samsung device, a Samsung phone, and an iPhone phone, they are all made of metallic objects, they all have glass objects, they all have camera, they all have, I mean, a whole lot of things. Sometimes you can even see that they all look the same. But what makes iPhone iPhone? What makes iPhone expensive, or what makes iPhone, meeting higher standards, is because they have good operating system. And what is the operating system here? They have good software. That is why it makes it so, expensive in the market. But when it comes to the physical device, both the Samsung device and the iPhone device are all metals. But what makes one expensive than the other is the operating system, and it is the software. So the cost of developing software is quite very, very expensive, because so much thinking goes into that, so much investment goes into that, so much algorithms and functionalities, and so many thinking goes into the development of the software, and that makes it quite very expensive. Right, let's move on. Then we also have the dynamic nature. The ways growing and adapting nature of software hugely depends on the environment in which the software works. If the nature of the software is always changing, new enhancements need to be done in the existing one. This is where software engineering plays a good role. So dynamic nature, what is dynamics? The ability of the software to change, to respond to specific demands, the ability of the software to play different functionalities at the same time. So now we have devices that are playing the role of they are playing multiple roles. It means that they are dynamic. Let's use the phone for example. Our phones, we have our time effect on our phone. We also have the phone we can use in taking pictures. They have high resolutions, just like a normal digital camera. We also have the phone that we can use it for some computational purposes, so we don't even need a calculator. So for you having a phone, the phone performs more functionalities, or the phone performs more duties and more things for you. It is even a storage device. We even store so many things in. We store pictures, we store videos, we record messages and other things that goes on and all that. And at the same time, it is also a platform for us to communicate to other users over the internet. So having the phone has more functionality. So it means that the phone is dynamic in nature. The ability for it to adapt different environmental conditions, different response, and the different areas in which they operate in. So that talks about the dynamic nature of a software. The software to function in Ghana here, the software to function in Russia, the software to function in China, the software to function in US, irrespective of the language barrier. So it means that what the software has the ability to function and respond in different environmental sectors. Right. And then we also have the quality maintenance. Better process of software development provides better and quality software product. So the quality of your software is how well the software can be maintained, or how well you can maintain the software. That is why most of the software companies or the IT companies comes out with updates and upgrades of their what? Of their software. So that what their software can meet the demand, their software can correct problems that have been occurred and all that. So you can get to know that we have various versions of applications that are being used. Let's use the phone industry for example. The first generations of Nokia and the current generations of Nokia that we are having has improved tremendously. Why? They have improved because the quality management towards the development of the product has increased. So because it has increased, the desires and the problems that they encountered earlier on has been resolved, and now the system or the software or the application or the device is now able to function effectively. Right, so that explains that. A software product can be judged by what it offers and how well it can be used. This software must satisfy the following grounds. Okay, so let's look at it. So this is about the characteristics of a good software. The characteristics of a good software. Right, it should be operational. The characteristics of a good software. We say that the software should be operational in terms of functionality. It should be transactionals in terms of maybe you having some transactions up and down, calculations and other things. You should be able to respond well. And then maintenance, the ability for us to maintain the software is also of a great importance. So let's break the three categories down well, so that it will give us a better understanding of what we intend to do. So under operational, it says this tells us how well software works in operations. It can be measured on the budget, the budget, as to whether we can get it or we can buy it, whether we have the means to get the particular product or the particular software. Operational budget. Usability, can we use the software when we buy it? Can we use the software? Will it function in the environment in which we want it to function? Meaning that what the usability of the software. And then efficiency, how well will it help us to work effectively? So if we consider the budget, if we consider the usability, now we have to look at the efficiency. I mean, if we are doing a manual way of, let's say, transacting our business or satisfying our customers, and we now decide to use the software, first we consider, can we buy the software? We also find out, can we get the experts or can we train ourselves to use the software? Then we come to efficiency. Will the software give us the expected results, or we have to go back to our old way of what? Of transacting our business? If the software can give us efficiency, efficiency means that we do not waste time attending to our customers. Efficiency in the sense that we have addressed issues of customers and we have met the satisfactions of our customer. It means that the software is performing well. Correctness. I mean, can the software come in to correct some things that we are doing with delays or with takes time? Can the software correct some of our problems? Functionality. Functionality is also of a great concern here. How well would the software behave, or how well would the software respond to our outcomes or our inputs? How will it function in our medium, in our working environment? How will it function if we send it to our users or we advertise that we have this product and that the product will be able to solve a specific task? How well can the users see the functionality of that particular app or software that we have developed? And then we have dependability. Can we depend on the software? Can we leave the software to behave or to respond well in the absence of any employee or any, let's say, user or any other person? Because sometimes there are systems that have been integrated with artificial intelligence. So in the absence of humans, the software can interact with people. So it means that what? We have put so much trust, we have put some confidence in the machine or the system we have developed, so that in the absence of any of our employers, maybe we are all asleep and then we want our software to respond to the needs of our customers who are globally. I mean, can the software respond to them well, so that when we come back the following day, we can see all messages and all interactions that have gone on with the software, so that we can address the issues accordingly? So it means that, can we depend on the software? Right. And then security. How secure are we using the software? Will the software expose us to our competitors, or would the software expose, let's say, sensitive information, the data we have collected about our employees? I mean, the information we have about our clients, and then the services we provide to them. And we have kept this document so well. When we give this information to softwares, when we give it to machines that and systems and applications that we have developed, can we trust the safety of that document that has been given? If that is achieved, then we can say that, oh, okay, I mean, the operationability of this software is good. And then we come to safety. The safety precautions that comes with the use of software. The safety precautions that comes with the use of software. How safe am I using this particular software? I mean, where maybe the electrical gadgets or the device that I'm having is having, let's say, health hazards on my system, or it is deteriorating my health, then it means that it's not safe for use. So it means that if we have applications that will be safe, I mean, test the issue of, let's say, the response to the user, let's say a hearing disability, maybe eye problem, or maybe neck problem, or any other thing. If the product that I'm having would, would, would affect me in another way, then it means that the safety of that problem, of that device or that system or that application is not guaranteed. Right, that explains that. Now we move on to the next thing, which is transactional. This aspect is important when the software is moved from one platform to the other. Transactionals. Can we use it to perform many transactions? Can we use it on this device and move that same application to another device? How would they behave? When I use my software on on a Windows application, how is it going to behave? When I use it on Linux, when I use it on Mac, how is the software going to behave in terms of transactions? Can it function well using Windows operating system? Can it also function well using Linux operating system? So it says that what? I mean the software to move from one platform to the other. That explains that. So under transactionals, let's look at that. We have portability, how portable it is, how simple it is. When we talk of portability, the easy handle. Is it easy for us to use it? Is it easy for us to handle it? I mean, to make sure that we are in control of the device that we are using. Interoperability. How well would it work effectively with other devices or with other platforms that we have? That explains the aspect of interoperability. And then reusability. I've used it for this purpose. Can I also use it for another purpose? If I can use it for that, then it means that I've accomplished the aspect of reusability. Use it for so many things, because we have applications that can perform specific tasks, and at the same time they have other things that they can also do, especially when you go to our ATMs. If our ATM is dormant or is not being active, sometimes it shows advertisement of some applications, it shows some advertisement of some product and services that is being run by the bank. Yes. And then adaptability. Is it able to adapt to other events, other systems? Maintenance. Now, this aspect briefs about how well a software has the capability to maintain itself in the ever-changing environment. In the ever-changing environment, there is noise at the background. There is the dog that is making the noise. So please just permit me for that, and let's focus and let's listen to what is going on. So let's look at maintenance. It says this aspect briefs about how well a software has the capability to maintain itself in the ever-changing environment. So let's look at, we have the modularity. We'll explain more of modularity when we go further. We also have the maintainability. We have the flexibility. We also have the scalability, and then yes, and then the scalability. So in terms of maintenance, we look at the modularity, we look at the maintainability, the flexibility, and then the scalability. So we'll explain modularity, we'll explain the maintainability, the flexibility, and then the scalability. In short, software engineering is a branch of computer science which uses well-defined engineering concepts required to produce effective, durable, scalable, in-depth and on-time software product. So after going through everything about what we have done in chapter 1, I also gave a detailed definition of what software engineering is. A branch of computer science which uses well-defined engineering concepts required to produce effective, durable, scalable, in-depth, and on-time software products. So time is a factor here. Sometimes we measure the performance, that how long will it take us to develop this software. And then once we have timed ourselves, it will help us to go through everything successfully. Software engineering interview questions. So after going through the chapter 1, I listed some few questions that will be of great importance for my students. They can have they can go through it, they can also read further and all that, and that would be of a great help for them. So software engineering interview questions has been designed especially to get you acquainted with the nature of questions you may encounter during your interview. for the subject of software engineering. What is software engineering? State the two techniques used to reduce software problem complexity. When do when you know programming, what is the need to learn software engineering concept? This question is quite good. And then, can you differentiate software, computer software, and computer program? What is modularization? So thanks very much for the first lecture, taking you through the concept of software engineering and what goes into software engineering. All right, so God bless you all, and I hope this video will be of great help to you. If you have any issue or something, you can send me a link. And then for more information, you can also visit our website for some questions. And then you can respond to the questions, and then we will know how well to respond to that questions. So once again, it's been powered by ProTechAfrica. Please like us on YouTube and Instagram and also Facebook, and then visit our website www.protechafrica.com. My email is there, my WhatsApp number is there. I mean, call me, let's chat, let's talk about technology, let's talk about computing, and everything will go on well with us. God bless you. Be safe.